guys, so now that we're done answering the activities and packet tracer activities in chapter 6, we can now proceed in the summary of the whole chapter. So chapter 6 is all about network layer. So the protocols of the OSI model network layer specify addressing and processes that enable transport layer data to be packaged and transported. The network layer encapsulation enables data to be passed to a destination within a network or on another network with minimum overhead. So this chapter focuses on the role of the network layer. It examines how it divides networks into groups of hosts to manage the flow of data packets within a network. It also covers how communication between network is facilitated. This communication between network is called routing. So the network layer or OSI layer 3 provides services to allow end devices to exchange data across the network. To accomplish this end-to-end transport, the network layer uses four basic processes. So the first one is the addressing end devices. End devices must be configured with a unique IP address for identification on the network. The second one is the encapsulation. The network layer encapsulates the protocol data unit PDU from the transport layer into packet. The encapsulation process adds IP header information such as the IP address of the source or sending and destination or receiving hosts. The third one is the routing. The network layer provides services to direct packets to a destination host on another network. To travel to other networks, the packets must be processed by a router. The role of the router is to select the best path and direct packets toward the destination host in a process known as routing. And the last one is the encapsulation. When the packets arrive at the network layer of the destination host, the host checks the IP header of the packet. If the destination IP address within the header matches its own IP address, the IP header is removed from the packet. Network layer protocols. There are several network layer protocols in existence. However, as shown in the figure, there are only two network layer protocols that are commonly implemented. So, the two here is the Internet Protocol version 4 or the IPv4 and the Internet Protocol version 6 or the IPv6. Encapsulating IP. IP encapsulates the transport layer segment or other data by adding an IP header. This header is used to deliver the packet to the destination host. The IP header remains the same from the time the packet leaves the source host until it arrives at the destination host. The process of encapsulation data layer by layer enables the services at the different layers to develop and scale without affecting the other layers. This means the transport layer segments can be readily packaged by IPv4 or IPv6 or by any protocol that might be developed in the future. Characteristics of IP. IP was designed as a protocol with low overhead. It provides only the functions that are necessary to deliver a packet from a source to a destination over an interconnected system of networks. The protocols was not designed to track and manage the flow of packets. So, the characteristics of IP is connectionless, best effort delivery, and media independent. IPv4 packet header. An IPv4 packet header consists of fields containing important information about the packet. These fields contain binary numbers which are examined by the layer 3 process. Significant fields in the IPv4 header include version, which contains a 4-bit binary value set 20100 that identifies this as an IP version 4 packet. Differentiated services or diffserv or the DS, formerly called the type service or the TOS field. The DS field is an 8-bit field used to determine the priority of each packet. Time to time con- contains an 8-bit binary value. Time to live contains an 8-bit binary value that is used to limit the lifetime of a packet. Protocol field is used to identify the next level protocol. Next is the source IPv4 address. So it contains a 32-bit binary value that represents the source IPv4 address of the packet. The source IPv4 address is always a unicast address. Next is the destination IPv4 address. So it contains 32-bit binary value that represents the destination IPv4 address of the packet. The destination IPv4 address is a unicast, multicast, or broadcast address. Limitations of IPv4. Through the years, IPv4 has been updated to address new challenges. However, even with changes, IPv4 still has three major issues. So IPv address depletion. IPv4 has a limited number of unique public IPv4 addresses available. Although there are approximately 4 billion IPv4 addresses, the increasing number of new IP-enabled devices, always-on connections, and the potential growth of less developed regions have increased the need for more addresses. Internet routing table expansion. A routing table is used by routers to make best path determinations. As the number of servers connected to the internet increases, so too does the number of network routes. Lack of end-to-end connectivity. Network address translation or the NAT is technology commonly implemented within IPv4 networks. Introducing IPv6. In the early 1990s, the Internet Engineering Task Force or the IETF grew concerned about the issues with IPv4 and began to look for a replacement. This activity led to the development of IP version 6 or the IPv6. IPv6 overcomes the limitations of IPv4 and is powerful enhancement with features that better suit current foreseeable network demands. Improvements that IPv6 provides include increased address space. IPv6 addresses are based on 128-bit hierarchical addressing as opposed to IPv4 with 32 bits. Improved packet handling. The IPv6 header has been simplified with fewer fields. And the next is eliminates the need for NAT. With such a large number of public IPv6 addresses, NAT between a private IPv4 address and public IPv4 is not needed. IPv6 packet header. The fields in the IPv6 packet header include version. This field contains a 4-bit binary value set to 0110 that identifies this as an IP version 6 packet. Traffic class. This 8-bit field is equivalent to the IPv4 differentiated services or the DS field. Flow level. This 20-bit field suggests that all packets with the same flow label receive the same type of handling by routers. Payload length. This 16-bit field indicates the length of the data portion or payload of the IPv6 packet. Next, header. This 8-bit field is equivalent to the IPv4 protocol field. It indicates the data payload type that the packet is carrying. enabling the network layer to pass the data to the appropriate upper layer protocol. Hop limit. This 8-bit field replaces the IPv4 TTL field. This value is decremented by a value of 1 by each router that forwards the packet. Source IPv6 address. So this 128-bit field identifies the IPv6 address of the sending host and the destination IPv6 address. So this 128-bit field identifies the IPv6 address of the receiving host. Host forwarding decision. Another role of the network layer is to direct packets between hosts. A host can send a packet to itself. A host can ping itself by sending a packet to a special IPv4 address of 127.0.0.1, which is referred to as the loopback interface. Pinging the loopback interface that's the TCP or IP protocol stuck on the host. Local host. This is a host on the same local network as the sending host. The hosts share the same network address. And the last is the remote host. This is a host on a remote network. The hosts do not share the same network address. Default gateway. The default gateway is the network device that can route traffic to other networks. It is the router that can route traffic out of the local network. So a default gateway routes traffic to other networks. It has a local IP address in the same address range as other hosts on the network, and it can take data in and forward data out. Host routing tables. Entering the netstat-r command or the equivalent route print command displays the three sections related to the current TCP or IP network connections. Interface list. List the media access control, the MAC address, and assign the interface number of every network capable interface on the host, including Ethernet, Wi-Fi, and Bluetooth adapters. IPv4 route table. List all known IPv4 routes including direct connections, local network, and local default routes. IPv6 route table. List all known IPv6 routes including the direct connectionless, local network, and local default routes. Router packet forwarding decision. So the routing table of a router can store information about directly connected routes. So these routes come from the active router interfaces. Routers add a directly connected route when an interface is configured with an IP address and is activated. Remote routes. These routes come from remote networks connected to other routers. Routes to this network can be manually configured on the local router by the network administrator or dynamically configured by enabling the local router to exchange routing information with other routers using a dynamic routing protocol. And default route. Like a host, routers also use a default route as a last resort if there is no other route to be desired network in the routing table. Directly connected routing entries. Table entries. When a router interface is configured with an IPv4 address, a subnet mask is activated. So the following two routing table entries are automatically created. C identifies a directly connected network. Directly connected networks are automatically created when an interface is configured with an IP address and activated. L identifies that this is a local interface. This is the IPv4 address of the interface on the router. A router is a computer. There are many types of infrastructure routers available. In fact, Cisco routers are designed to address the needs of many different types of businesses and networks. So, branch. Teleworkers, small businesses, and medium-sized branch sites include Cisco Integrated Services Routers or the ISR G2 second generation. 1. Large businesses, organizations, and enterprises includes the Cisco Catalyst Series switches and Cisco Aggregation Services Routers or the ASR. So service provider, large service providers includes a Cisco ASR, Cisco CRS3, carrier routing, and 7600 series routers. Router, CPU, and OS. Like all computers, tablets, gaming console, and smart devices, Cisco devices require a CPU to execute OS instructions such as system initializing, routing functions, and switching functions. The highlighted component in the figure is the CPU of a Cisco 1941 router with, with heatsink attached. The heatsinks helps dissipate the heat generated by the CPU. So this is the highlighted component. Router memory. A router has access to volatile or non-volatile memory storage. So volatile memory requires continual power to maintain its information. When the router is powered down or restarted, the content is erased and lost. Non-volatile memory retains its information even when a device is rebooted. Specifically, a Cisco router uses four types of memory. So that is the RAM, the ROM, NVRAM, and the flash. So this is volatile memory used in Cisco routers to store applications, process, and data needed to be executed by the CPU. Cisco routers use a fast type of RAM called Synchronous Dynamic Random Access Memory or the SDRAM. ROM is This non-volatile memory is used to store crucial operational instructions and a limited iOS. Specifically, ROM is firmware embedded on an integrated circuit inside the router which can only be altered by Cisco. NVRAM, this is non-volatile memory, is used as the permanent storage for the startup configuration file or the startup config. Flash, this is non-volatile computer memory used as permanent storage for the iOS and other system-related files such as log files, voice configuration files, HTML files, backup configurations, and more. When a router is rebooted, the iOS is copied from flash into RAM. Connect to a router. So Cisco devices, routers, and switches typically interconnect many devices. For this reason, these devices have several types of ports and interfaces that are used to connect to the device. Like many networking devices, Cisco devices use light emitting diode or the LED indicators to provide status information. An interface LED indicates the activity of the corresponding interface. If an LED is off when the interface is active and the interface is correctly connected, this may be an indication of a problem with that interface. If an interface is extremely busy, its LED is always on. LAN and WAN interfaces. So the connection on a Cisco router can be grouped into two categories: in-band router interfaces and management ports. Click the highlighted areas in Figure 1 to view more. So similar to a Cisco switch, there are several ways to access user exec mode in the CLI environment on a Cisco router. These are the most common. Console. So this is a physical management port that provides out-of-band access to a Cisco device. Out-of-band access refers to access via a dedicated management channel that is used for a device maintenance purposes only. Next is the secure shell or the SSH. So it is a method for remotely establishing a secure CLI connection through a virtual interface over a network. And the next one is the telnet. So it is an insecure method of remotely establishing a CLI session through a virtual interface over a network. Unlike SSH and Telnet, Telnet does not provide a securely encrypted connection. So, router boot up process. So, there are three major phases to the boot up process. The first one is performing post and load bootstrap program. So, during the power on self test or the post, the router executes diagnostics from ROM on several hardware components including the CPU, RAM, and an NVRAM. Then, second is locating and loading Cisco IOS. So, the iOS is typically stored in the flash memory and is copied into RAM for execution by the CPU. If the iOS image is not located in the flash, then the router may look up for it using a trivial file transfer protocol or the TFTP server. And the last is locating and loading the configuration file. So the Bootstrap program then copies the startup configuration file from NVRAM into RAM. So this becomes the running configuration. If the startup configuration file does not exist in NVRAM, the router may be configured to search for a TFTP server. So this is the task where before you configure. So this is basic switch configuration steps. So these are the steps. Review the initial switch configuration tasks. So in configure the device name, you should put the host name. To secure user exec mode, you should put the line console and the password, then log in, then exit. Then to secure remote telnet or SSH access, you need to put the line VTY015, then the password, then log in. For the secure privilege exec mode, you can type enable secret password, and for secure all password in the config file, service password encryption. So for the provide legal notification, put the banner MOTD delimiter message delimiter, then configure the management SVI. Next is basic router configuration steps. So this is similar to configuring a switch. The task listed in figure 1, so it should be completed when configuring initial settings on a router. So if you want to save the configuration, then just copy running config, then config startup, then config. Configure router interfaces. For routers to be reachable, the in-band router interfaces must be configured. There are many different types of interfaces available on Cisco routers. In this example, the Cisco 1941 router is equipped with 2 gigabit Ethernet interfaces, Gigabit Ethernet 0/0, and Gigabit Ethernet 0/1. Then a Serial 1 interface wired or the WIC consisting of two interfaces, Serial 0/0/0 and Serial 0/0/1. Then verify interface configuration. There are several commands that can be used to verify interface configuration. The most useful of this is the show IP interface brief command. The output generated displays all interfaces, their IPv4 address, and their current status. So the configured and connected interfaces should display a status of app and protocol of app. Anything else would indicate a problem with either the configuration or the cabling. You can verify connectivity from the interface using the ping command. Cisco routers send 5 consecutive pings and measure minimal, average, and maximum round-trip times. Exclamation marks verify connectivity. So that is the end of the slide, and I hope you learned something from this video. Thank you for watching, guys. Bye!